Hello to everyone. Welcome to my channel. This is Guru Brahmam, having 20 years of teaching experience. In this video, I am going to solve JEE Mains PYQ questions. So let us start. So what is the first question asked? First question, delta U is equal to isochoric work, isobaric work, adiabatic work, and isothermal work. Delta U. So first of all, we have to know FLT. What is FLT? First law of thermodynamics. According to first law of thermodynamics, we know that delta U is equal to Q plus W. So first option is given as isochoric work. What is meant by isochoric process? Isochoric process means delta V is equal to 0. So what is delta V? Change in the volume. Isochoric means iso same, choric means volume, so same volume. Delta V is equal to 0. We have derived a formula previously. What is that? W is equal to minus P external into delta V. If delta V is equal to 0, then work done will be equal to 0. If work done is equal to 0, then delta U is equal to Q. So it is asked delta U is equal to Q, not W. So option 1 is wrong. Option 2, let us see. In option 2, it is asked isobaric work. So isobaric process. What is isobaric process? What is iso? Iso means same, baric means same pressure. So P is constant. P is a constant. And we know that according to first law of thermodynamics, delta U is equal to Q plus W. So work done is equal to minus P external into delta V, we know. So P is constant. If P is constant, will the work be is equal to 0? No. Work done is equal to minus P external into delta V. So delta U is equal to Q plus W. It is not, delta U is not equal to W, because Q is not equal to 0. So this is also not the option, because delta U is not equal to work. Delta U is equal to Q plus W in isobaric process. Q plus W, right? Next, third option given as adiabatic work. Adiabatic process, what is meant by adiabatic process? We have known that adiabatic process Q is equal to 0. We have studied that. So delta U, according to first law of thermodynamics, delta U is equal to Q plus W. Q is equal to 0. Then delta U will be equal to W. Yes, we got the answer, because Q is equal to 0. Next, isothermal work. Isothermal process. What is isothermal process? Isothermal process. What is isothermal process? Isothermal, same temperature. So delta T is equal to 0. If delta T is equal to 0, previously we have studied that delta U is equal to NCV delta T. If delta T is equal to 0, automatically delta U will be equal to 0. So from first law of thermodynamics, we have studied that delta U is equal to Q plus W. If delta U is equal to 0, delta U is equal to 0. So 0 is equal to Q plus W. So delta U is not equal to W. Delta U is found to be equal to 0. So the answer will be adiabatic work, because in adiabatic work, delta U is equal to W. So that is the answer. Let us go with second question. Which one of the following equations does not correctly represent the first law of thermodynamics for the given process involving the ideal gas? Cyclic process. So let us take cyclic process. So in cyclic process, already we have studied that. See, this is cyclic process. For example, a process is taken from state A to B, B to C, C to D, and D to again A. If the initial state is again regained, then we say that if initial state is again regained, then that is called a cyclic process. This is what a cyclic process. So in the cyclic process, initial temperature T initial. So after certain process, after certain steps, again initial state of the system is regained. That means initial temperature is equal to final temperature. That means delta T is equal to 0. If delta T is equal to 0, then automatically previous here if you see delta T is equal to 0 in isothermal process. If delta T is equal to 0, then automatically delta U will also be equal to 0. If delta U is equal to 0 according to first law of thermodynamics, so 0 is equal to Q plus W. Then Q will be equal to minus W. Q will be equal to minus W. So the question asked is does not correctly represent. That means the wrong one. So first one is correct statement, correct expression. Next is isothermal. Next given is isothermal. Isothermal process already we have studied here. 0 is equal to Q plus W. So then if isothermal already studied, already here it is explained. So 0 is equal to Q plus W. Automatically Q will be minus W. So second statement or expression is also correct. Next, adiabatic process. Adiabatic process delta U is equal to minus W. Here already we have studied adiabatic process. See here adiabatic process. In adiabatic process what we have seen, delta U is equal to W. Not delta U is not equal to minus W. Okay. So here given delta U is equal to minus W. What we have got, delta U is equal to W. From here it is known that delta U is equal to W. So this one will be the wrong statement or wrong expression. Isochoric process. So what is isochoric process? Let us see. What is a isochoric process? Isochoric process. What is isochoric process? Iso, same, core. Already we have studied that isochoric process also. So what here if you say isochoric process, delta U is equal to Q. So delta U is equal to Q. So this is correct statement. So the asked question is which is not correct. So adiabatic process, this will not be the correct one because delta U is equal to W. Right? So next let us go with the third one. Third question. Question number 3. In the question number 3, among the following set of parameters that represents path function. So functions or properties, thermodynamic properties classified into two types. What are those? State function and path function. What is meant by state function or state properties? The properties which depend upon the initial state and final state but does not depend upon the path. Whereas path functions depend only upon the path. So only two path functions we have studied, heat and work. Here given first option, in the option A, Q plus W. From first law of thermodynamics we have known that Q plus W is equal to delta U. Delta U is change in internal energy. So this change in internal energy are state functions. This is what a state function. State function. Internal energy is state function. So A is a state function. P already I said that path functions are two. Path function. Two important path functions we have to remember. What are those? Heat and work. See, B is Q. Q means heat energy. Heat. C, W, work. So B and C are correct. Whereas coming to D option, if you see, H minus Ts. H minus Ts is equal to G, which is called as Gibbs energy. What is that? It is Gibbs energy. What is G here? Gibbs energy. So Gibbs energy is a state function, not path function. So H minus Ts is equal to G, where we study in the concepts of Gibbs energy. So H minus Ts gives you G, which is Gibbs energy. Gibbs energy is a state function. So what is the question asked? The question asked is, among the following set of parameters that represents path function, heat and work are path functions. So the answer will be this one. Next, question number 4. So what is that question? Let us see. During the compression of a spring, so for example, let us take the spring is considered to be the system. During the compression of a spring, the work done, compression means you are pushing this spring. That means work is done on the system. If work is done on the system, then the sign, according to first law of thermodynamics, the sign, what sign we have to take? W is equal to positive. So work is done on the system, we are compressing it. So why you are taking positive? According to sign convention, we have to take it as positive. So work is done on the system, compression work. So work done is how much? 10 kilojoules. And 2 kilojoules escape to the surroundings. When you are compressing it, some heat energy is left from the system. So Q is left from the system. So what you are writing, Q is equal to minus 2 kilojoules. Why you are writing minus? Because heat energy, when it is leaving the system, according to sign convention, we have to take it as minus. So Q is equal to minus 2 kilojoules. Then what is asked? The change in the internal energy is, according to first law of thermodynamics, we know that delta U is equal to Q plus W. So delta U is equal to Q is minus 2 kilojoules, work done is 10 kilojoules, that is equal to minus 2 plus 10 is plus 8 kilojoules. So the answer is plus 8 kilojoules. Next question, let us go with the next question. Coming to the next question. So next question, what is the question asked? The question asked is, what happens when methane undergoes combustion? What happens when methane undergoes combustion? Here methane is undergoing combustion. In systems A and B respectively, here given system A, system B. System A is adiabatic system. System B contains diathermic container. Say for example, combustion of methane. Question number 5. So CH4 plus O2 gives rise to CO2 plus H2. Okay. If you balance this equation, 4 hydrogen atoms are there, multiply with 2, 2 plus 2 oxygens are there, 4 O2, right? Now let us take methane, considering that methane is gas. So let us see here. So methane is gas, oxygen is gas, carbon dioxide is gas, whereas water is liquid. Okay. In system A, adiabatic system. So system A, this is system A, and this is system B. Okay. System B, A, B. So this is what adiabatic. Already we have studied that in adiabatic Q will be equal to 0. Diathermic container. Diathermic container means this wall is diathermic. That means it will allow the flow of heat. Which will allow the flow of heat? Wall will allow the flow of heat. Heat can move outside. Heat can enter into the system. So this is the diathermic container. Diathermic container means the container that is containing diathermic wall. Diathermic wall means which allows the flow of heat through that. Okay. So adiabatic process means Q is equal to 0. Now what is happening? Initially the volume of the gas is more. Initially volume, so how many moles? 1 plus 2, 3 moles are there. After combustion, how many moles? Only 1 mole. That means volume is decreasing. So volume is decreasing. Initial the volume is this much. So volume decreases. Volume decreasing means compression. Compression means work is done on the gas. That means work is positive. Work is positive. Q is equal to 0. According to first law of thermodynamics, we know that delta U is equal to Q plus W. W is equal to 0 means delta U is equal to Q. Delta U is equal to W because Q is equal to 0. So work is done on the system. That means work done is positive. The delta U is also positive. Positive means delta U have another formula, that is delta U is equal to NCV delta T. So what is delta T here? Delta T means T final minus T initial. N is positive, CV is also positive. When will be delta U positive? When will be delta U positive? If T final minus T initial is positive, then delta U will be positive. That means final temperature is more than initial temperature. So what happens when you are when methane is undergone combustion in this container? What is happening? The volume is decreasing. Volume decreasing means work is done on the system. If work is done on the system, as heat energy is not going out, that work done on the system is converted into heat energy, so that the temperature rises. So temperature rises. This will be the answer. Coming to system B, temperature remains same. See, if you go with the options, system A, in all these, if you see, temperature remains same. Okay. Third option also, temperature falls. Fourth option, temperature falls. There is only one option where you are finding temperature rises. So temperature rises. Whereas in B, the possibility, if you look into, volume is decreasing. Volume is decreasing. That means work is done on the system. Compression. So work is done on the system. That work, already it is said that diathermic container. That means heat can flow out. When heat can flow out, according to the options given, we can say that the work done on the system is converted into heat, and that heat is left out. Q went out. So the work done on the system is converted into heat, and that heat escaped into the surrounding. So here the temperature is remaining same, because whatever the work is done on the system, that amount of work is converted into heat, and the heat has escaped. So that is about the answer. Next question, let us go with question number 6. We are speaking about question number 6. In the question number 6, what is asked? Which of the following properties will change when the system containing solution 1 will become solution 2? So this is solution 1, this is solution 2. In solution 1, what is given? 10 moles of solute X plus 10 liters of water. When this is converted into this, there is change in the mass. Here 10 mole of solute X, 10 liters of water. Here 1 liter of solution 1, 1 mole of solute X, 1 liter of water. So if you clearly see here 10 moles, 10 liters of water, here 1 liter of water, 1 mole of X, 1 liter. So there is change in the mass. If there is change in the mass, there are some properties which does not depend upon the mass. Those properties are called as intensive properties. So what are intensive properties? Intensive property here does not depend upon mass, independent on mass of system, independent on the mass of the system. Here two properties are independent on the mass of the system. When solution 1 is converted into solution 2, this is solution 1, this is solution 2, mass is changing, the solution is similar solution, so only mass is changing, right? Only mass is changing because it is solute X. With solute X and water we have made solution 1. The solution 1 is taken and again it is mixed with the same solute X, and water. So here what are the substances present? The same substances are present here. So substance is not changing, only the mass of the substance is changing. So there are two properties. What are those two properties? Molar heat capacity and density. These are what? Intensive properties. These intensive properties does not depend upon the change in the mass. So molar heat capacity does not change, density also does not change. But coming to concentration, so solution 1, in solution 1, if you take molarity is equal to, what is molarity? Number of moles of the solute by volume of solution in liters, or number of moles of solute present in 1 liter of the solution. Number of moles is 10 moles by volume is also 10 liters. That is equal to 1 mole per liter. So this is molarity of or concentration of solution 1. So if you take solution 2, let us consider solution 2. So molarity is equal to number of moles. Let us take here 1 liter of solution 1. See, if you take 1 liter, then how many moles are there? 1 mole. So here we have 1 mole. Again 1 more mole of solute is asked. That means 2 moles. So 2 moles by, so this is 1 liter and this is also 1 liter. Totally 2 liters. So 2 gets cancelled. Again we are getting 1 mole per liter. That means the concentration of solution 1 is equal to concentration of solution 2. So concentration is not changing, density is not changing, molar heat capacity not changing. Who changes? Gibbs free energy change. Why does Gibbs free energy change? Gibbs free energy is extensive property. Gibbs free energy, or it is also called as a Gibbs energy, is a extensive property. Extensive property means that depends upon the mass. extensive property. So Gibbs energy is extensive property which is depending upon the mass. So from solution 1 to solution 2, what is changing? What is changing? Mass is changing. When mass changes, automatically Gibbs energy changes. So the answer will be Gibbs energy. Gibbs energy is changed. So will change when the system containing. Okay. So that is about question number 6. Next, coming to question number 7. In question number 7, what is the question asked? So these 3 graphs are given, and what is asked? So in the question, what is asked? Let us see that. In the question asked is, an ideal gas undergoes cyclic transformation. So that process which are given there are cyclic process. Already by looking at the graph, we can find that they are cyclic process. From the point A and coming back to the same point by tracing the path A to B, B to C, C to D, D to A, as shown in the 3 cases above. So in the above 3 cases, it is very clearly seen. See, there is a loop. Especially in cyclic process, we find loop because the initial state of the system becomes final state. So A to B, B to C, B to C, C to D, and D to again coming to A. Okay, again coming to A. So initial state is equal to final state. That means initial temperature is equal to T initial is equal to T final. Already we have studied this concept. So T initial, when T is initial is equal to T final, delta U is equal to NCV delta T, which is equal to NCV, okay, T final T initial delta T, T final minus T initial, that is equal to NCV into T final minus T initial 0, that is equal to 0. So here delta U is equal to 0. Here is also cyclic process, A to B, B to C, C to D, D to A. Initial state is equal to final state. Here also delta T is equal to 0. Then here also delta U will be equal to 0. Here A to B, B to C, C to D, D to A again. Initial state is equal to final state. So initial temperature will be equal to final temperature. Delta T is equal to 0. So delta U is equal to 0. So in all these three cases, what you are finding? Delta U is equal to 0. See, delta U will be equal to 0. Let us see here. Second option, delta U in the case 1 is equal to delta U in the case 2 is equal to delta U in the case 3. In all these cases, delta U is equal to 0 because delta T is equal to 0. Because this is a cyclic process. Okay. Next, coming to the question number 8. So statement type question is given. What is the statement 1 given to us? When a system containing ice in equilibrium with water is heated. So now there is ice. There is ice here. Ice is in equilibrium with some water here. Water is also present here, right? Right. So when ice is in equilibrium with water, generally it will be at 0 degrees centigrade. We know that 0 degrees centigrade is freezing point of water. At freezing point of water, ice converts into water and water converts into ice. So at freezing point, there will be an equilibrium existing between ice and water. At a freezing point, there will be an equilibrium existing between ice and water. So ice converts into water, water converts into ice. The rate of conversion of ice into water will be equal to rate of conversion of water into ice. So there is an equilibrium. water liquid. So now you are heating it. What you are doing is heating it. When you are heating it, what happens? Heat is absorbed by the system and there is no change in the temperature of the system until whole ice. So what you are doing? Now you are heating it. So when you heat it, what happens? You are giving some heat energy. That by using that heat energy, this ice converts into water. So heat energy is used only to convert from solid state into water. It is not used to increase the temperature until all the ice is converted into water. So that is at 0 degrees centigrade this happens. At that freezing point of any liquid, what happens when you heat it? The total heat what you are supplying will be used to convert the solid state completely into liquid state. Once after complete conversion of solid state into liquid state, then slowly whatever the heat you supply, that will be used to increase the temperature. Until completely ice is converted into water, temperature does not rise. So the statement 1 is correct. Statement 2, let us come to statement 2. At melting point of ice. So melting point, what is the melting point of ice here? Melting point is also 0 degrees centigrade, freezing point is also 0 degrees centigrade. So when you are heating, what happens? The ice melts slowly. Whatever the heat you are supplying, see, ice means water. See, in ice, see, water, what? Between one water molecule and another water molecule, what is present? Hydrogen bonding is present. What's present? Hydrogen bonding. This is also called as intermolecular force. This is one molecule, this is another molecule, one water molecule, another water molecule. Between two water molecules, there will be some attractive force. That's intermolecular force. Hydrogen bonding is also a type of intermolecular force. So when you are supplying heat energy, that heat energy is used to break these intermolecular forces. When these intermolecular forces are broken, that means if there is a decrease in the intermolecular force, automatically what happens? These molecules move farther so that they convert into water. So when the force decreases, they move farther apart. They get the configuration of liquid and get converted into liquid. So that is what here at melting point of ice, there is absorption of heat in order to overcome the intermolecular forces of attraction within the molecules of water in ice, and kinetic energy of the molecules is not increased at melting point. So whatever the heat you are supplying, it is not to used to increase the kinetic energy, just it is used to break the intermolecular force. So statement 2 is also correct. So both statement 1 and 2 are correct. Next, coming to question number 9. Already this we have discussed. So state properties, state variables, state functions. So what is meant by state function? Again we are speaking the variables are the thermodynamic properties that depend upon only the state of the system, does not depend upon the path of the system. So here internal energy U is a state function. Volume is a state function. Whereas we have only two path functions. What are those? Heat, work. The remaining here, enthalpy is also state function. So totally among the following, the number of state variables: state function, internal energy, volume, enthalpy. Whereas heat energy is what? Path function, right? So the answer will be 3. Next, coming to question number 10. The number of endothermic process from the following is: I2 gas is converted into 2I gas. See, I2 gas. I2 means here it is in the form of molecule, whereas it is converted into I atoms. If a molecule is to be converted into atom, then you have to supply energy to break this bond. When you supply energy, then that is endothermic process. So A is a endothermic process. Coming to HCl. HCl is converted into HCl gas is converted into H plus Cl gas. Again, what is happening? The bond between H and Cl is broken. To break this bond, again some energy is to be provided. It absorbs energy and convert into atoms. When net energy is absorbed, then we say that it is an endothermic reaction. H2O liquid is converted to gas. H2O liquid is converted into H2O gas. To convert liquid into gas, and it is to be heated. When you heat it, then automatically it becomes an endothermic process. Next, C plus O2 gives rise to CO2. It is a combustion process. In combustion process, heat energy will be released. Heat will be released. When heat is released in a reaction, when there is a net release of energy, then it will be exothermic reaction. What is that? Exothermic reaction. So this is what exothermic reaction. Dissolution of ammonium chloride in water. So this is also we need to remember this dissolution of ammonium chloride in water. So this is water. You are adding NH4Cl. When you add NH4Cl, overall some energy is used to break the lattice and some energy is used will be released as hydration enthalpy. Overall energy is absorbed. As energy is absorbed, again this is a endothermic process. So this is also endothermic process. So totally there are 4 endothermic process. Okay. Next question is the total number of intensive properties. So already we have studied what is meant by intensive property. Intensive property means independent on mass. What is that? Independent on mass of the system or quantity of matter present in the system. So volume here intensive. Let us go with the extensive. Intensive. Volume depends upon the mass of the substance. So it is extensive. But if you are given molar volume, like molar volume is intensive. Molar volume. Molar heat capacity. Molar heat capacity. Molar heat capacity means heat capacity of 1 mole. Heat capacity for 1 mole of the substance. Molar volume means volume occupied by 1 mole of the substance. So molar heat capacity is intensive property. Whereas if you take heat capacity is extensive. Heat capacity is extensive. Next, molarity, concentration. Molarity or what it is, concentration. Molarity, concentration. Concentration is intensive property. Next, EMF of the cell is intensive property. Gibbs energy is extensive property. Molar mass of 1 mole of the substance, that is intensive property. Mole, if the mass changes, number of moles changes. For example, 16 grams of methane is equal to 1 mole. If mass changes like 32 grams, 32 grams of methane, 2 moles, right? So when the mass is changing, number of moles are also changing. So mole comes under extensive property. So the answers here are molar heat capacity, molarity, EMF of the cell, and molar mass. There are 4 intensive properties, right? EMF of the cell also does not depend upon the mass. Molarity also does not depend upon the mass. Okay. Next, coming to here, we are speaking about again questions on enthalpy change, first law of thermodynamics, enthalpy change, and calculation of work, right? So question number 1. So what is that question number 1 given? A piston filled with 0.04 mole of an ideal gas, right? There is an ideal gas in a cylinder. That ideal gas is occupying some volume initially, right? So question number is C. So there is a piston filled with 0.04 mole of an ideal gas, 0. expands reversibly from 50 ml to 375 ml, right? 0.0. Here is gas, question number 1. Here is gas, right? Number of moles is 0.04. Initial volume is 50 ml, right? Let us see this. Initial is 50 ml, final 375 ml. Initial volume is 50 ml. Volume final is 375 ml given at a constant temperature of 37 degrees centigrade, which is equal to, if you want to convert it to absolute temperature, you have to add 273 plus 37 gives rise to 310 Kelvin, right? As it does, it absorbs 208 joules of heat energy. The value of Q and W. First of all, we have to remember that this process is happening at constant temperature. So when temperature is constant, we know that delta T is equal to 0. If delta T is equal to 0, then automatically delta U is equal to 0. From first law of thermodynamics, we can write that delta U is equal to Q plus W, right? So 0 is equal to Q plus W. Q is equal to minus W. So if you already, it absorbs 208 joules of heat. 208 joules of heat. It is absorbing. So Q absorbed means Q is plus 208. Here Q is equal to minus W, or you can write W is equal to minus Q. Then what will be? Q is equal to plus 208 joules. Then automatically W is equal to minus 208 joules. So the answer will be the first option. Q is plus 208 joules, W is equal to minus 208 joules. Okay, understood. Next, question number 2. For the complete combustion of ethanol combustion is given. Reactants number of moles delta N, delta Ng, that is number of moles of gaseous products minus number of moles of gaseous reactants. Gaseous products are, say, this 2CO2. So 2 minus, this is gas again, right? In the question number 2, 3, then that is equal to -1. Okay, the amount of heat produced as measured in bomb calorimeter. So bomb calorimeter, so this is like a bomb calorimeter. Here the combustion is, here the combustion is done at constant volume, right? Combustion of fuel is done at constant volume. Heat produced as measured in bomb calorimeter is 1367.47 kilojoules per mole. Heat is released when what is burnt? Ethyl alcohol. You are taking some ethyl alcohol here, you are burning it. When you are burning it, that means combusting it, heat energy is released. Okay, so this is happening at constant volume. We have studied previously that delta U is equal to QV. Heat energy released at constant volume is equal to delta U. And as heat energy is released, we take it as negative value. So delta U is equal to minus 1364.47 kilojoule per mole, right? So this is delta U given. And what is asked? Assuming ideality, the enthalpy of combustion. So what is asked? Enthalpy is asked. So enthalpy of combustion, delta H. See, what is the relation between delta H and delta U? Delta H is equal to delta U plus delta NGRT. Okay. So delta H is equal to delta U minus 1364.47 plus delta N is -1 into R. R value given here as 8.314. 8 point, right? So let us see, delta H given as 1364.47. This you to mention kilojoules plus minus, okay, -1 into R value given as 8.314 into temperature is 25 degrees centigrade. 25 degrees centigrade means 273 plus 25, 298 Kelvin. So this is delta U is minus. Why minus? Because energy is released. So if you add these two, then what do you get? Minus 1366.95 kilojoule per mole, right? So the answer will be first option. So once again, in bomb calorimeter, what is happening here? Ethyl alcohol is combusted. When ethyl alcohol is combusted, what happened? Some amount of heat energy is released, and that heat amount of heat energy released is at constant volume. That amount of heat energy released at constant volume is delta U. And why you are taking negative? Because amount of energy is released, exothermic. So relation between delta H and delta U is delta H is equal to delta U plus delta N RT. Delta N means number of moles of gaseous products minus number of moles of gaseous reactants. So you get the answer, right? Question number, let us go with question number 3. So what is question number 3? Let us see that. So in the question number 3, graph is given at two different temperatures. It is given, graph is given at two different temperatures. Okay, question number 3. Consider a reversible isothermal expansion. What is that? A reversible isothermal expansion. So for this reversible isothermal expansion of an ideal gas in a closed system at two different temperatures T1 and T2, where T2 greater than T1, the correct graphical depiction of dependence of work done on the final volume. Okay, on the final volume. Right? Let us see. We know, see, work done and volume. The relation asked is on x-axis. What did they take? Work done. On y-axis, log V. We know that work done for reversible isothermal process, we have derived a formula that work done is equal to minus nRT log V final by V initial. Right? If you write in detail, W is equal to minus nRT log V final minus V initial. So on the x-axis, if you see, the question asked is mod W. When you take mod W, this minus also becomes plus. Then what you can write? nRT log V final minus nRT log V initial. V initial, right? So now this is equation of a straight line. So graphs, what graphs you are finding? You are finding straight line graphs. Now let us equate with the equation of a straight line. So y is equal to mx plus c. On y-axis, what was taken? Work done. On x-axis, what is taken? Log V final. Log V final. Right? So here intercept is negative. Negative intercept. Negative intercept means the graph must intersect on negative y-axis. Negative y-axis. Right? And what is slope? Here slope is equal to m, which is equal to nRT. Here temperatures are mentioned. So temperature is mentioned. And it is mentioned that T2 greater than T1. That means more the temperature, more the slope. That means the graph which is having T2 will have more slope because T2 is greater. As T2 is greater, the slope for T2 will be more. As T1 is lesser, the slope for T1 is less. In all these, you are finding T2 has more slope than T1, T2 more slope than T1, T2 have more slope than T1, T2 have more slope than T1. But if you intersect on y-axis, if you prolong this, see T1 is intersecting on positive y-axis. Here T2 intersecting on negative y-axis, T1 is also intersecting on negative y-axis. Here both on positive y-axis. Here both on positive y-axis. No, here at 0, and both are similar, right? So more appropriate answer will be here this T2. If you prolong this graph, you are finding that it is intersecting on negative y-axis. Negative y-axis. It is also slowly intersecting on negative y-axis. So more the slope, more the temperature, more the slope, and the intercept, it should intersect on negative y-axis. So the answer will be this one, right? Next question number 4. Understood? Right? The difference between delta H and delta U, delta H minus delta U, when the combustion of 1 mole of heptane, heptane means heptane C7, hepta, heptane alkanes, CnH2n plus 2. General formula is CnH2n plus 2, CnH2n plus 2. So 2 into 7, 14, 14 plus 2, 16, plus O2 combustion, CO2 plus H2, right? Balance this equation, 16 hydrogens are there, so 8 to 16, 8 plus 2, here let us 7, okay, because there are 7 carbon atoms, 7 carbons, 7 to 14, 14 plus 8 is 22, so 11 oxygens. Here it is given in the question that heptane is liquid, so this is in liquid state, oxygen gaseous, carbon dioxide gaseous state, water liquid state. So delta N, let us calculate delta N is equal to number of moles of the gaseous products minus number of moles of the gaseous reactants, which is equal to 7 minus 11, which is equal to minus 4. We know the relation between delta H and delta U. Delta H is equal to delta U plus delta N RT. The question answer is delta H minus delta U. Delta U coming this side, then automatically it will be delta N RT. So delta N RT means delta N, what is delta N? Minus 4. So minus 4 RT. So where is minus 4 RT? So here is minus 4 RT. Understood? Right? So next question number 5. Coming to question number 5. Let us see. Question number 5. In this question number 5, an ideal gas is allowed to expand from V initial is 1 liter, V final is 10 liters, right? Delta V is equal to 10 minus 1, that is equal to 9 liters. Okay. So an ideal gas is allowed to expand from 1 liter to 10 liters against a constant external pressure. P external given as 1 bar. The work done kilojoules. Work done in kilojoule. So we have a formula to calculate the work done. Work done is equal to minus P external into delta V, which is equal to minus 1 bar into 9 liters. 9 liters. So that is equal to minus 9 bar into liter. Right? So 1 bar into liter is equal to dash joules. 1 bar is equal to 10 power 5 Pascal into 1 liter is equal to 10 power minus 3 meter cube. Okay, which is equal to 10 power 5 Newton per meter square into 10 power minus 3 meter cube, which is equal to 10 power minus 5 into 10 power minus 3, 10 power 2 meter square, meter cancel, Newton into meter. This is equal to 100 joule. So 1 bar into liter is equal to 100 joule. So what do you get here answer? That is equal to minus 900 joule. If you want to convert it into kilojoule, what you write? 900 by 1000 kilojoule, which is equal to minus 0.9 kilojoule, right? So what is the answer? Minus 0.9 kilojoule. Understood? Next, coming to the question number 6. Let us see question number 6. In question number 6, 5 moles of an ideal gas at 1 bar pressure and 298 Kelvin is expanded into vacuum. For example, there is gas here. There is a gas. This is vacuum. Vacuum means the space where nothing is present. No air, nothing. Here there is gas, right? Initially it is like this. Now you are making a hole to this. What happens? Gas slowly expands into this vacuum. Slowly expands into this vacuum. Right? And what will be the work done by that gas? Work done is equal to minus P external into delta V. This is the formula which we have studied. That is equal to vacuum. There is nothing here. There is no opposing force. There is no external pressure. Okay, work done, force into displacement. There should be some opposing force. Then only the work will be done. If there is no opposing force, then automatically work will not be done. That means external pressure is equal to 0. That means it is equal to 0. External pressure is 0. 0 into delta V, that is equal to 0. So work done in expansion of a gas into vacuum will be always equal to 0 because external pressure is equal to 0. Next to question number 7, let us see. Choose the correct option from free expansion. Free expansion is nothing but expansion into vacuum. Expansion into vacuum, now only we have seen that work done is equal to 0 of an ideal gas under adiabatic condition. Already adiabatic condition, we have already studied what is meant by adiabatic condition. Adiabatic condition means Q is equal to 0. When Q is equal to 0, W is equal to 0. According to first law of thermodynamics, we know that delta U is equal to Q plus W. So delta U is equal to Q is 0, W is also 0, and delta U will be also equal to 0. So when delta U is equal to 0, we know that delta U is equal to NCV delta T, then delta T will also be equal to 0. So delta T is equal to 0, W is equal to 0, Q is equal to 0. So what you get? Fourth option. Understood? So I hope so you followed the video well, understood the concepts well. Thank you for watching the video up to the end. If you like this video, please like, share and subscribe and click on bell icon so that when I upload new videos, you will receive the notification. Thank you very much. Thank you for your watching.